Most people hear supervised learning and imagine an AI sitting in a classroom while a teacher checks its homework. Then, they hear unsupervised learning and imagine the same AI skipping class and doing whatever it wants. Surprisingly, that comparison is not completely useless. The real difference is simple. In supervised learning, the AI is trained with correct answers. In unsupervised learning, it must search for patterns without being told what those answers are. But here's the real question. Can a machine learn something useful when nobody tells it what is right or wrong? Let's start with supervised learning. Imagine showing an AI thousands of pictures labeled cat or dog. Every picture comes with the correct answer, so the model can make a prediction, check whether it was right, learn from the mistake, and improve. It is called supervised because the training data acts like a teacher. The model is not left completely alone. It has examples and answers to guide it. Supervised learning is commonly used for two types of problems. The first is classification, where the AI chooses a category, such as spam or normal email, fraud or legitimate payment, disease or no disease. The second is regression, where the AI predicts a number, such as a house price, delivery time, sales figure, or future energy demand. Now imagine giving the AI thousands of customer records, but no labels. You do not tell it who is a loyal customer, who is price sensitive, or who may leave. Instead, you ask it to find groups and hidden patterns by itself. That is unsupervised learning. It looks for similarities, differences, unusual behavior, and natural clusters inside the data. Think of a box filled with mixed buttons. In supervised learning, someone has already labeled them by color, red, blue, green, and yellow. The AI learns using those labels. In unsupervised learning, there are no labels. The AI may organize the buttons by color, size, shape, or number of holes. It discovers structure, but humans still need to interpret what that structure means. A practical example is customer segmentation. A business may have thousands of customers but may not know how to divide them. An unsupervised learning system can study purchasing habits and identify groups such as frequent buyers, discount hunters, seasonal customers, and high-value customers. The system discovers the groups, but a human still decides how the business should respond to them. A simple case study comes from banking. A supervised model can learn from past transactions already labeled as fraudulent or legitimate, and then predict whether a new transaction looks suspicious. But an unsupervised model can search for unusual transactions without needing a list of known fraud cases. This can help discover new types of suspicious behavior that fixed labels may have missed. Both methods have weaknesses. Supervised learning usually needs large amounts of accurately labeled data, and labeling can be slow, expensive, and biased. Unsupervised learning does not need labels, but its results can be harder to understand. The AI may discover a pattern that is mathematically interesting, but completely useless for the real problem. Finding a group does not automatically explain why that group matters. These ideas grew from decades of work in statistics, pattern recognition, and machine learning. Researchers developed supervised methods to learn from known outcomes and unsupervised methods to discover hidden structures. Neither method is automatically better. The right choice depends on the data available and the problem being solved. So in one simple line, supervised learning learns from examples with correct answers, while unsupervised learning searches for patterns without labeled answers. One learns with guidance. The other explores the data and tries to organize the confusion. Welcome back to the AI Studio, where we make artificial intelligence simple, visual, and slightly less painful. But if machine learning can already discover patterns, what makes a neural network different? And how can layers of artificial neurons learn patterns too complex for ordinary models?